So if you look at the question, they're asking us to figure out the standard enthalpy change of combustion of ethanol. What do you think is the equation for the combustion of ethanol?
Um,
Like, do you know what the formula of ethanol is?
yeah, isn't it? Like wait,
It's C2H5OH. But what's the equation for combustion? It's basically reacting it with oxygen to produce carbon dioxide and
yeah,
H2O. So this is two carbons and this is three water molecules, and you can balance out the oxygens. This is going to be 3O2, right? So
yeah,
so this is the combustion of ethanol. The enthalpy change for this reaction would be called the combustion of ethanol. And this is the enthalpy change that they're looking for. They're asking you to find what is the standard enthalpy change of combustion of ethanol, right? Now, according to the
yeah.
Hess cycle, the way you do this is you create another path, right? That was what
Mhm.
was that was what we were doing yesterday, right?
Yeah.
So we're given three reactions, and I'm going to look at those three reactions. The first one is the enthalpy change of formation of carbon dioxide, right?
Yeah.
What is the equation? Whose enthalpy change are they talking about? Which reaction are they talking about? Like this one over here.
Um, the carbon dioxide. One.
But what's the equation? It's the enthalpy change of formation of carbon dioxide, right? So the elements would be forming,
Carbon dioxide.
they would be forming carbon dioxide, right? So
Yeah.
what I'm going to do is I'm going to start creating this path.
I'll get down there. We can probably read Margaret and then we
Okay.
can
So I'm going to start creating this path. You see carbon dioxide over here, right?
Okay.
Yeah.
So I'm going to form carbon dioxide from its elements. So it would be two carbons
Okay.
plus two oxygen molecules, and I'm going to keep water as it is. I'm not touching water.
Yeah,
So water remains exactly the same.
after 5 o'clock.
So
Fine. Okay. I'll
so what's the
I'll print it out. I'll print it.
Amal? What's the enthalpy change? It's minus 393, right?
Yeah.
But multiplied by two, right?
Yeah.
Yeah.
Because
So
it's two carbon dioxide molecules that are getting produced.
yeah.
I said then the next one, it's the enthalpy change of formation of water, right?
Yeah.
So what we can do is I have water over here, I can form it.
Project.
I can form water
Oh, I
molecules.
wonder. Oh, yeah. Okay. Yeah.
So the two carbons and the oxygens
No line software.
are going to remain as is. I'm not going to disturb them.
Yeah, if you can do it, that's fine. I've never used it before, but I've
So
heard
it's
of
going
it.
to be two carbons
Okay, fine. Okay.
plus 2O2.
Do they want to see timelines or are
I'm trying to make water over here, so it's going to be 3H2
they? Okay.
plus I think 1.5 O2
Okay.
molecules.
Yeah. All right. No. Okay. Fine. I'll see you at 6.
So
Text me
Okay.
your address
th-
then. I'll see
this is minus 286 times 3. So I'm just going to repeat what I just did. Okay, I'm going to repeat everything. This is the equation that they're asking for. They're asking you to find the enthalpy change of combustion of ethanol. So you have ethanol and you're burning it and you're producing carbon dioxide and water, right? So this is the enthalpy change that you're trying to figure out. According to Hess law, you know that if you create this other path, that path would have the same energy change as this one, right?
Yeah.
So the information that's provided to you is you're given the enthalpy change of formation of carbon dioxide. So what you did was that you saw carbon dioxide, you formed it from carbon and oxygen. So that's minus 393 times 2. Uh, you didn't touch water, so that's three water molecules as it is. Then you're given the enthalpy change of formation of water. So you see water over here, and you can form water with 3H2 and 1.5 O2 molecules, and you can form water molecules, right?
Yeah.
And the two carbon and two oxygen molecules are there as it is. And so now the last thing that they're giving us is the standard enthalpy change of formation of ethanol. So ethanol over here would be formed from its elements. These are the elements for forming ethanol. And the value for that is minus 277, right?
Okay. Yeah.
So I've been able to create this other path. Okay? Is that clear?
Yeah.
So one path is the enthalpy change of one path is the same as the enthalpy change of this other path, right?
Mm-hmm.
So your enthalpy change for the reaction, I mean this enthalpy change is going to be what? It's going to be plus 277.
Yeah.
Why plus 277? Because you have to go in the opposite direction. Then it
Okay.
then it would be minus 286 times 3, and then it's going minus 393 times 2, right?
Yeah.
So you're taking this path. You're taking this path. So your enthalpy change would be equal to this other path. What is the answer that you're getting?
I got minus 1,367.
So that's B, right?
Yeah. B.
Okay. Now the issue with this is that I mean it takes a very long time and you have to be very creative with hair cycles because it's kind of hard to make, right? Uh,
Yeah.
by looking at these reactions, I mean by looking at this, you would have to figure out how to create this other path, right? So we just did that, but there's a shortcut, and the shortcut is very simple. The easier method is I'm going to wrap this off, and so this is the reaction of the enthalpy change that you're looking for, right?
Yeah.
So let me get rid of this. Okay, so this is the reaction of the enthalpy change you're trying to look for. Now, what is given in the question? You're given the enthalpy change of formation. You're given delta HF of this particular molecule, right? You're given delta HF of carbon dioxide as well. That's
Yeah.
given. Plus, you're given the delta HF of H2O as well, right? That's also given. And the delta HF
Yeah.
of O2 is by default already known because you don't need to form them. So the enthalpy change of formation for this element would be zero, right? Is that clear?
Yeah.
Achha, so the conditions for applying the formula and to do the question without actually drawing the Hess cycle is that for a particular reaction, if you know the enthalpy change of formation of all the reactants and all the products, the simple formula is that the enthalpy of that particular reaction, and I'm talking about this one, okay, the one that we just found out, minus
Okay.
1367. The enthalpy of that particular reaction is basically the sum of the enthalpy of formation of products minus the sum of enthalpy of formation of the reactants. And
Okay.
let's do that. We're going to get the same expression that we got over here. What are the enthalpy of formation of products? You have water and you have carbon dioxide, right? So what is water? That's minus 286. But there are three water
Yeah.
molecules, so that's 3. What is carbon dioxide? Carbon dioxide over here is minus 393, but that would be multiplied by 2, right? So these are my products. Minus my reactant, which is ethanol, and ethanol is minus 277. And the other one is O2, which is 0. Amal, is this clear?
Yeah.
So now you can have a look. So now you can have a look, and you can see that this expression and that expression that you got earlier, they are exactly the same. TK is
Mm-hmm.
so what you have to do is the enthalpy of formation of the products minus the enthalpy of formation of the reactors. Just do that. So try and solve this other question. You have to find the enthalpy change of this particular reaction.
Okay.
So so try and solve this. Uh, what's given? The enthalpy of formation of H2S, that's given. The enthalpy of formation of H2O, that's also given. The enthalpy of formation of SO2 is also given. The enthalpy of formation of O2 is going to be 0. What you have to do is just sum up the enthalpy of formation of products and subtract it from the enthalpy of formation of the reactants. Try and do that. And tell me what the answer is.
Uh, okay.
And multiply by the moles as well. 2H2S means that minus 21 would be multiplied by 2.
Okay. I got B.
You got B, that's, so basically, just tell me what the expression is. That's going to be product minus reactants. So 2 water molecules, that's minus 286.
Yeah.
Times 2. 2 SO2 molecules, that's minus 297. Times 2, that's your products, and minus the
Yeah.
reactant, which is minus 21 times 2. And the other one is 0. Right?
Yeah.
Is this what's giving you B?
Yeah, that's what I did.
Okay, so B is the correct option. Try and figure out the enthalpy change of combustion of methane. First, tell me what the equation is.
Methane is like CH4.
Yeah.
So
So what's the what's combustion of methane? Combustion is a reaction with what thing? It's a reaction with
with like heat.
no with
So it'll be like with oxygen. So it be CH4 plus O2 plus CO2 plus water.
yeah. I mean these are your products, and you can balance it. It's going to be 2 water molecules, and there's going to be 2 oxygen molecules. So this is the reaction whose enthalpy change you have to figure out, right?
Yeah.
So use the data that's given.
Okay. Is it A minus 892?
Okay, so that's 8. That's A. Now quickly try and find what the answer to this is. the unknown enthalpy change.
Okay. Is it D 242?
I think it's 209. It's going to be. Did you multiply NO2 by 2? Like it's minus. I mean,
Yeah.
the product is minus 520, and the other one is 33 times 2. And you subtract the reactant from it. That's minus 696, right?
Um.
Just let me check just 1 second to confirm. I think it was 209 for this one. So it's minus 520 plus 33 plus 66 basically. And then you subtract or you add what? 696?
Yeah.
It is D. D, that's D. So I said now let's
Okay.
now here's a tricky one. He's asking for the combustion of propanone. So I'll just give you the equation. It's propanone is C3H6O. And its combustion equation is going to look like this. There's going to be CO2. Plus there are going to be 3 water molecules. And this is how many? 9 oxygens. So I think there would be 4 O2s, right? So you're given this.
Yeah.
Now, how would you... Now the problem is, how would you find the enthalpy change of this reaction? Like, do you know the enthalpy of formation of propanone? I mean that is given, right? I mean that's given over here, minus 254.
No, I'm not really sure.
No, it's given.
Yeah.
T gets given over here. T gets written over here. I said, but are you given the enthalpy of
Oh,
formation?
okay.
But are you given the enthalpy of formation of carbon dioxide? I mean, for the formula to work, you need
No.
enthalpy of formation of all these substances, right? The only one I mean, these two you're sure of. You know propanone,
Yeah.
it's given. And you know about O2 because that's 0. You don't form O2, it's already formed. You can remember this, elements have enthalpy changes of formation which are equal to 0. I said the whole issue now is
Okay.
the whole issue is these two. What do you do with these two? Can you tell me what's the equation for combustion of hydrogen?
So which one? Hydrogen?
I mean, he's saying that combustion of hydrogen is minus 286. So what's the reaction? Like hydrogen, right? It's H2. What is combustion?
So would it just be H2 plus O2?
Yeah. What would be formed?
Water? Would it just be water?
Yes. And this would be half O2, right? To balance it. What's the combustion of carbon, right? Combustion of carbon would be carbon plus O2, right? And it would form CO2, right? So
Yeah.
now the issue is, I mean, you're calling it combustion of carbon and combustion of hydrogen, right? Can you call it the enthalpy of formation of H2O? I mean, is this equation also equal to the enthalpy? Like, by definition, what is enthalpy of formation? When a substance is formed from its elements, right?
Yeah.
So this water molecule is getting formed from its elements. So the thing you're calling the enthalpy of combustion of hydrogen is basically the same thing as enthalpy of formation of water. Amal, is this point clear?
Yeah.
Because they represent the same reaction. Like enthalpy of combustion of hydrogen is that 1 mole of H2 is burned and it produces water, right? That's enthalpy of change of combustion of hydrogen. And when you say enthalpy of formation of water, it's basically 1 molecule of water is formed from its elements, right? So it's basically the same reaction. So these two enthalpy changes are exactly the same. They represent the same reaction. Do you get this point? Amal, is this clear?
Yeah. Mm-hmm.
Achha, now similarly, enthalpy change of combustion of carbon is the same as enthalpy change of formation of CO2 because
Okay.
because they represent the same reaction. Like carbon burning in oxygen to produce carbon dioxide. What is enthalpy change of formation of carbon dioxide? That 1 mole of carbon dioxide is produced from its elements. I mean, it's the same exact reaction. So, so this value over here is basically, I mean, you can call it the enthalpy of formation of H2O. And this value over here, you can call it the enthalpy of combustion of carbon. Sorry, formation of carbon dioxide. So in this way,
Okay.
you'll get the values of carbon dioxide formation and water formation. So tell me what the answer is now for this.
Okay.
You get the point, right?
Yeah.
Do you tell me the answer now?
Um, is it C?
Minus 78.6.
Yeah. That's what I got.
Okay, that's fine. So let's try and do this one now. He's saying that a student tried to calculate the standard enthalpy change of formation of ethane, right? Can you tell me what the equation is? Like formation equation.
We see
Yeah.
C carbon plus hydrogen equals C2H6.
So it's going to be carbon plus hydrogen equals C2H6, right? And
Yeah.
you can balance it. It's going to be 2 carbons and 3 hydrogens, right?
Yeah.
And this is a student calculated the standard. This is delta HF. I mean, the enthalpy change would be called the enthalpy change of formation, right?
Yeah.
Now, he's saying he used a method based on the enthalpy changes of combustion. Now, there's another formula which is that if enthalpy changes of combustion are given, okay, that's the second formula.
Yeah.
That if you know in a reaction, you know the enthalpy change of combustion of all the reactants and all the products. Then the enthalpy of that particular reaction is going to be equal to the enthalpy of combustion of the reactants minus
Yeah.
the enthalpy of combustion of the products. So it's going to be the opposite. If enthalpy of combustion are being used, then you're going to do reactant minus products. Is this clear? It's exactly the same thing like we were doing for formation. But for combustion,
Okay.
it becomes reactant minus products. Okay, so coming back to this, what's given? He's saying he used correct values for the enthalpy change of combustion of ethane, which is minus 1560. So this is minus 1560. And hydrogen, that's also known, that's minus 286. But he used an incorrect value for the standard enthalpy change of combustion of carbon. This is unknown, that's X. We don't know what that value is. He did all the calculation and his final answer was minus 158. We also know what the answer is, minus 158. The only thing that you need to find out now is this value of X. So can you try and calculate, because the final answer is also known, that if you do reactant minus products for combustion, the reactants are 2 carbons, so that's 2X.
Okay.
And this is minus 286 times 3. And minus products, which is minus 1560, and there's only one of them. You just have to find the value of X.
So is it D minus 272?
That's fine. Now this one is also about combustion. Like you're given the enthalpy of combustion of carbon and hydrogen and butane. So how do you find the enthalpy of this reaction? It's going to be reactant minus products. Try and find the answer for this one.
Okay. Is it A?
No, it shouldn't be A. It's going to be reactant minus products, right? The reactants are 4 carbon, so that's minus 394 times 4. The other reactant is 5H2, so that's minus 286 times 5. And minus the products. So C4, that's minus 2877. So this would become plus.
Oh, I forgot. Oh, I only put one minus, so it stayed minus. I didn't. Oh, okay.
Because this value was minus already, so it became plus.
Yeah. Oh, so it's B then, I think.
Okay, so it's B. And the rest of the questions are also similar. So let me just find some. Without doing calculation, which one of the expressions is the correct one?
I think it's A.
Remember, it's enthalpy of formation that's given, right?
Yeah.
So it's going to be product minus reactants. So the product is Mg, which is Mg is 0 because it's an element. You don't have to form it. Then it's KClO3. So that's minus 391. No, it's going to be product minus reactant. So you have to start over here. So 3 times MgO, that's 602.
Mm-hmm.
So I think it's going to be C. 3 times minus 602. I mean, these are your products. The other one is minus 437. So that's your products. And minus your reactants. So it's going to be products minus reactants, right? Is that clear?
Yeah. Yeah.
So which is why it's going to be C. So I'm just going to summarize what we did. We learned that there were 2 ways of actually we learned that there was a Hess cycle method. You had to draw the Hess cycle. But if there's any reaction where reactants are turning into products, and you know the enthalpy of formation of the reactants as well as the products, so you just have to do product minus reactants, and you'll find the enthalpy change for this particular change. And vice versa, if you know the enthalpy of combustion of the reactants as well as the enthalpy of combustion of the products,
Yeah.
you have to do reactant minus products, and you'll get the enthalpy change for this particular change that's happening. Is that clear?
Yeah.
So, as in most of the other questions are very similar, okay? So it's just you just have to apply formulas and you'll get the answer. So we'll continue with this the next time.
Okay.
Okay then. Take care. Allah Hafiz.
Love this.